All right, guys, thanks so much for being willing to watch this video, and I'm sorry again about class time today. Hopefully it won't happen again. I wanted to take some time in class today to tell you how to turn off all of those millions of alerts you're getting in a Google Classroom. If you go into any class in your Google Classroom, you can find this three-line thing in the upper left-hand corner and click on it. And then you'll have to go all the way down to the bottom. You can't see it when it first pops up because all your classes are in the way, and find settings. Click on settings. And then you want to turn off that you want to receive email notifications. Now, if you turn this on, you can customize a whole bunch of settings. So for example, if you'd like to get a notification when I grade your work, but not when I post your work, then you can customize that. This will turn off all your email notifications, but you will still get emails from your teachers, which I feel like is what's most important. So if your inbox is just like unusable right now because it's filled up with Google Classroom crap, turn this off and like reclaim your life. I wanted to go over a couple of problems that we had on the Bell work that you had some trouble with. Evan's family took a road trip to Niagara Falls. Evan fell asleep 5% of the way through the trip. If Evan fell asleep after they had traveled 30 miles, what was the total length of the trip? So remember, we can use that part over whole equals percent over 100. So he fell asleep part of the way through the trip. The percent always goes over the 100 right here. And then that was after they had traveled 30 miles. And I don't know how much the total trip was. So then I can just cross multiply. I get 3,000 equals 5x. All I have to do is divide 3,000 by 5. And so I know that the trip was 600 miles. That part over whole equals percent over 100, I think, is key for these word problems. And then I think this was the one that you guys thought was pretty confusing, so I wanted to teach you how to do it a different way. If 75% of a number is 165, so again, you can still use that part over whole equals percent over 100. So 75% of some number that I don't know is 165. I can do 100 times 165. That just gives me 16,500 equals 75x. And then I just divide both sides by 65. So 16,500 divided by 75, I get x equals 220. I don't actually need this. It is unimportant information to me, but just to double check, 10% of that same number is 22. Let's see if we get the same number. So that is 2200 divided by 10x, or excuse me, equals 10x. Divide both sides by 10. Guess what? I get x equals 220. And then I need to find 85%. So part over whole equals percent over 100. I'm finding 85% of this number, so this is the whole. So we get 100x equals 85 times 220. So that equals 18,700. Divide both sides by 100, and I get 187. So again, this step was unnecessary. I could get the information I needed from this first piece and then move straight on to the last step. I also wanted to go over a couple of problems that you had with the IP. This was the one where we were comparing the ice cream dots. First of all, I apologize for the number of gender divided things that you're going to see in this class. It's hard to find studies that aren't always separated by gender. I do my best, but occasionally I can't find what I need without using it. But just know that if I'm using it, it's because I couldn't find anything else that was better. So the first question was, what does each dot represent? It doesn't have anything to do with how much time they took to eat the ice cream. Each dot is just a person who ate ice cream. So you could have literally just said each dot is a person. The dot itself does not represent how much time it took. Where that dot is placed is how much time it took. And then you're having some trouble describing the shape. I want you to remember there's not a lot of options. You can say symmetric. You can say left skewed. Oops. You can say right skewed. You can say two peaked if it like has two hills. And that's about all you know right now. Some of you are just making up random stuff like, oh, it's pretty well spaced out. No, that's not shape of the distribution. So let's take a look at these. Draw a little curve that kind of goes over the top and along your dots. See this long tail out to the right? The female is right skewed, and so is the male. Both are right skewed. Although the female is much more right skewed, they are both right skewed. So you should have said right skewed for those. And then it says compare the variability. Some of you are just having trouble with the definition of the variability. It's not the range, you don't subtract. The variability is just smallest to largest. So let's see, for the females, they were spread out between about what looks like 13 to about 106. So you could say the females are 13 to 106. The males were about maybe 12 to, I don't know, 49. Again, that doesn't have to be perfect. I wasn't looking for that. And then if you're going to compare, you should say something like the females were much more spread out than the males. So it's not just giving me the variability, it's actually comparing it by saying the female are more spread out than the males. They reach all the way to 106. All right, I want to revisit frequency tables today because we're going to be learning about histograms, and you're going to need to be able to use frequency tables to complete your histograms. We use frequency tables to display how many times a particular point occurs in data. So if we have some raw data, we can organize that into age groups. That turns this into categorical data, not quantitative data. I can't find an average of an age range. So this is categorical. And then my frequency is just how many fit. And you've seen this table before. I think we said it was like kids in a movie theater or people in a movie theater. And remember, the relative frequency is the percent. So the first thing I would need to do is find the total. So 7 plus 5 is 12, plus 4 is 16, plus 6 is 22, plus 1 is 23, plus 2 is 25. So this is always going to be out of 25. Find the relative frequency, I just do 7 divided by 25 and turn that into a percent. And we're going to keep it lazy today and just leave those as decimals. So that's 0.28. 5 divided by 25 is 0.2. If the lack of a place value bothers you there, you can put that and that. 4 divided by 25 is 0.16. 6 divided by 25 is 0.24. And 1 divided by 25 is 0.04. And 2 divided by 25 is 0.08. So frequency table would just have the counts. The relative frequency would have the percentages. Relative frequency compares the category frequency total to the total number of individuals. We've already filled this out. All right, so for histograms, I want you to make sure you have your pen and pencil, give yourself a new title, histograms, and then put today's date, which is September 3rd. So what are histograms? A histogram is a type of data display that groups data together. It is not a bar graph. It does have bars, and there are things that are in common, but I want you to remember that a bar graph was always for categorical data. A histogram is what you would use when you need to deal with quantitative data, but it groups that data together. So it's kind of this weird gray area because it takes quantitative data and turns it into ranges, which then become categorical. Histogram presents continuous, which means it could be like 60, 61, 62, 63, or anything in between, often quantitative data, whereas the bar graph represents categorical data exclusively. So bar graphs are only categorical data ever. This could be a categorical or quantitative depending on how you arrange your numbers. The nice thing about this is just like stem and leaf plots, just like dot plots, we can use these to analyze the shape, the variability, and the center. So if I draw myself a little curve here, I would say my shape it's not perfect, it doesn't have to be, but I don't see an obvious tail. So we would say that that's symmetrical. The variability is between 60 and 90. So we don't know for sure where those pieces of data were, but somewhere between 60 and 90. And the center has to be a little bit more of an estimate. I usually write how many are in each group inside the box, and then that helps me find the center. So this box, there was 3 in that group. There was 3 in that group. There was 8 in this group. There was 10 in this group. There was 5 here, and there was 2 here. So if I add all those together, 3 plus 3 is 6, plus 8 is 14, plus 10 is 24, plus 5 is 29, plus 2 is 31. There are 31 pieces of data. Half of 31, if I do 31 divided by 2, that gives me 15.5, which means this, can't write 15.5, which means the 16th piece of data is the center. So I just add these up. 3 plus 3 is 6. 6 plus 8 is 14. The 16th piece of data is going to fall in this group. So the center is between 75 and 80. Again, I think Jaden Woods told us one day that this is just like the median. Yes, exactly. It's where the middle number would be. I don't know for sure which of these 10 pieces of data it is, but it's in there somewhere. Once the data has been gathered, we need to determine consistent intervals, make a frequency table, title and label our display and axes, and make sure the bars are connected. We're going to save this activity for when I see you, which will not be Tuesday, it'll be next Wednesday. So we're going to make our own histogram. So we'll work on that next time. All right, so let's say the histogram is already made. Again, you can find your shape by sort of drawing a loose curve. This time I have a right tail, so this is what we would call right skewed. The center, let's see, there's 12 here. There are 8 here. There are 3 here, 1 here, 2 here, and 2 here. So that means if I add it up, there are 12 plus 8 plus 3 plus 1 plus 2 plus 2. 2 plus 8 is 10. 13, 14, 15, 16, 17, 18, carry the 1. There are 28 pieces of data. So that means half of 28 is 14. So about the 14th piece of data would be the center. Well, there are 12 here, which means the 14th pieces of data falls somewhere in here between 6 and 9. So the center is between 6 and 9, which makes sense if it's right skewed. There are very few, but these stretch out here to make a right tail. And the variability, the lowest piece of data is a 3. The highest piece of data is 24. So it's between 3 and 24. We want to make a frequency table of the histogram. All we have to do is turn this into ranges. So if we've got 3 to 6, the frequency for that there would be 12 here. From 6 to 9, there were 8 here. From 9 to 12, there were 3 here. From 12 to 15, there was 1 there. From 15 to 18, there was 2 here. And then 18 to 21, there was 0. And then, sorry, I'm squishing this up down here, 21 to 24, there was 2 here. So that's my frequency table. If I wanted to turn these into percentages, I could put that right here. I would have to find the total, and I would divide to find the relative frequency. So the frequency table and the histogram are really closely related. We could not get the original data set back from this histogram. No, we could not. So while we know there are 12 pieces of data here, I don't know exactly what they are. There are 12 pieces of data that fall somewhere between 3 and 6. So maybe that is 12 threes, maybe that is 6 threes and 6 fours. There's no way for me to know. There's no way to get the original data set back from the histogram. Histograms are approximations. Because I can't get the original data set back, I don't know exactly how many pieces there were, then it's difficult for me to say it's anything but an approximation. They are approximate. So why do we use them? They are great at giving you a rough idea of shape, variability, center of data without overloading viewers with information. They may be useful to study specific ranges of data independently, but you won't be able to tell the position of each data point. You could do that with a dot plot, you could do that with a stem and leaf plot. You cannot do that with a histogram. All right, so your job now is to do your IP on histograms. Since we had to cancel class today, I definitely don't mind if you wait until after next class to turn this in. So let's see, let's change the due date of that. It was originally supposed to be on Monday at midnight because of Labor Day. Let's do that. Let's see, it will make it due on, I'll see you again on Wednesday. So we'll make it due on Wednesday, September 9th at midnight. That'll give you a chance to ask questions. We can go over the project that we were going to do in class on on Wednesday. And then that way I'll give you it'll be fine. I'll give you the rest of the time to work on your project. All right. Thanks, guys. I appreciate you. Have a great weekend. Love you all.